Hello there, and welcome to this open mic session as a part of the Disruptive Innovation Festival. We provide the platform and you provide the voice. I'm very, very pleased today to be joined by Chris Daniels from Airlander, Aviation's Future. I understand that we had a few technical difficulties the first time we tried the session. I'm very pleased to report that we have had no problems so far, and touch wood, we won't have any further problems. So I hope that some of you who tuned in the first time and were unfortunately disappointed have been able to join us on this occasion as well, because I know that Chris is extremely keen to receive your questions and input and comments, and to give you a bit more information about what is a very interesting project. Just so they know also that we have some sort of videos that provide a bit more information and background about this project. We are going to cover some of those topics in the session, so it's not essential viewing, but it might be very interesting if you haven't seen them already to go back and look at those. They're all on the event page. I think there's two separate videos. So I'm joined today by Chris Daniels from Airlander. There are two ways in which you can submit questions to Chris. The first is via the Google Hangout or Google Plus function. So that will either appear in the bottom left-hand corner of as a tab on the video screen if you're on our thinkdiff.co event page, or it'll appear on the right-hand side in a stream if you've clicked on that tab. The other way, if you don't have a Google account that's not permitting you to submit questions, is to use Twitter. So that's the ThinkDiff hashtag. That's ThinkDiff with just a single F. And we'll be collating those questions and feeding them through as part of our discussion with Chris. I also will let you know that we've got a special treat for you at the end. Towards the end of this session, we're going to be doing a live tour of the hangar, and we will be seeing the craft. So Chris will take us, is in the hangar right now, on the place where the hangar is right now, and he'll be picking up his camera and walking around a little bit with us, and you'll be able to ask him questions about the things you see, and also get to see what is a spectacular and really interesting piece of technology. So without any further ado, I'm going to introduce Chris. Chris is the head of partnerships and communications at Airlander, or hybrid air vehicles. He's formerly in the British Army, many years experience in finance and sponsorship. Most recently, he was head of Lloyd's TSB activation sponsorship of the London 2012 Olympic and Paralympic Games. So welcome, thanks for joining us today, Chris. It's good to hear and see you. Yes, thank you. And I should say that I think the reason why everything failed last time is I'm sitting in a 800, 900 foot long hangar, 300 meters long, that's sort of in the middle of nowhere, and we don't have BT cables or any landlines. So everything's connected via microwaves and etc. So things tend to fluctuate quite a lot here, technology wise. This session is brought to you by a microwave. That's a great takeaway, and so that's a great takeaway at the end of our fourth week of this festival. I just want to kick off, Chris. So there is some of this content in the videos, but I just wanted to ask, maybe you could tell us a little bit about the history of Airlander and hybrid air vehicles, and how it came about, and maybe some of the impetus behind it. Yeah. Well, the history, we started as a company in 2007, and really we were set up because the founder of our company realised airships had a whole bunch of fundamental issues. They're good at doing niche roles and they're good at doing advertising. They're very eye-catching, but they don't fulfil a whole wide range of roles. And the story goes that he met Barnes Wallis, the guy who did the bouncing bombs in the Second World War. Before he did bouncing bombs, he was doing airships in the UK in the 1930s. And Barnes Wallis came up with a whole bunch of issues with airships, and broadly they can be summarised as, that they're not very good on the ground, so the ground handling's poor. You need a lot of people to literally haul them to the ground on ropes, etc. And if you see old pictures, it's a kind of 100 people doing this. The materials technology when airships were having their heyday was woefully inadequate compared to what it is now, and there's lots of issues about crosswinds and how they relate to twins. And the way you solved all those problems was in effect mixing a wing and an airship, and so that's what hybrid air vehicles were set up to do. We created a whole load of
computer-aided design, prototypes that then grew into 10-meter, 18-meter long test prototypes that were flying around Cardington, just on the outskirts of Bedford, from 2007 to 2010. And then we won a big US Army contract that allowed us to build a full-scale one. So we've now got this huge, huge aircraft that's 92 meters long. It's sitting in the hangar. We'll show it you later. And in effect, it looks a bit like 2 or 3 airships put together, but it's fundamentally, it's an airship plus an aeroplane plus a bit of a helicopter, all rolled into one unique disruptive technology.
And the second question I sort of have for you is sort of linked to that. Maybe you could talk a bit about what is the sort of technology behind this? Like, how does it work? How do you get this enormous craft in the air? You know, how is it? Is it the same like an airplane? Is it jets? Maybe you could tell us a little bit about that.
Okay. I'd say in terms of what it does and what it, why it existed. It exists because it does something that nothing else can do. And if a wing can fly around, if you make a wing lighter and lighter than air because you fill it with helium, you basically have a more efficient wing. And what that leads you is to increased endurance and significantly increase. So our spec is that we can go up to 3 weeks without refueling, which is sort of ludicrous in modern terms. You can increase the payload. So if you compare a wing and a wing with helium, if you think you carrying heavy shopping from your local supermarket, if you attach a whole load of helium balloons to that shopping, you'll be able to carry more shopping. It's exactly the same principle with our aircraft. So you can increase your payload. Because of how we fly, we can land and take off from pretty much anywhere. As long as it's, in technical terms, the engineers describe it as long as it's flat-ish, we can land and take off. And that includes water, it includes ice, it includes desert, it includes grass, gravel, dirt strips, etc. And all of that adds up together, so you've got an amazing amount of fuel efficiency, and therefore it's very green, it's very low emissions, whether that's noise or nitrous oxides or carbon dioxide. So our carbon footprint is incredibly low. And where we think we're going with this is because of all those capabilities, which are sort of completely new. What we're thinking is we're going to skip out stages of normal technological evolution. So in the same way that when mobile phones went to emerging market countries, so Africa, basically nobody bothered putting fixed line telephony in. They just skipped it and just went straight to mobiles. And we think we'll be doing the same sort of thing we're having a lot of interest from austere locations, remote locations like Canada, like Africa, where rather than building a road or a railway or a canal, you just skip that expense and that infrastructure and skip all the resource expenditure, and you just have something that can do all the things that a truck or a railway car or a canal boat can do, and you just go from A to B without all that. So I kind of think of it as almost, in passenger terms, a portable Eurostar service that we've created. So A to B really conveniently from wherever you want to wherever you want, without having to invest billions in infrastructure.
Cool. Yeah, that's. I like the idea of a floating Eurostar service.
Yeah.
Well,
that's kind of where it all started, really. That was, the airships of old were floating ocean liners, and we've moved on a lot from there. We don't really, we're as different to an old airship as probably a Ferrari is to a Model T Ford. But in effect, it's using the same lighter than air technology to just make things more efficient so you can do more things.
Yeah, that's interesting. I think you've sort of started to talk a little bit about some of the purposes of this technology. So you've highlighted some of the immediate things that I'm assuming you'd guess you can either do very, very soon is the almost immediate application. So, going to hard to reach places, very long haul trips and transporting very large amounts of things because you've got the weight capability. So I wondered if you might outline just very quickly a couple of those very specific purposes. I've mentioned a couple I think already, but maybe do you see also answer the question of, do you see the usage and purpose evolving in the future? I mean, can you see it becoming a general purpose transformation? And actually, I know I'm piling on the questions a bit, but our first audience question, and just to remind people, you can submit those either via Google Hangout or Twitter using the ThinkDiff hashtag, the 1F, from Dale Walker, is how long do you think it will be until you can offer passenger flights?
Wow. Okay.
Short or longer. So let's take that first set of questions first, and we'll come back to the specific passenger carrier one. So I mean, maybe you could talk a little bit about how you see the purpose of it evolving.
Yeah. It's a really pertinent question. What we've got is something that's disruptive, and the next question is, well, how do we use it? So we're, to a certain degree, responsive to what other people think, how they would use it. Because we're a manufacturer. We don't intend, if we can help it, to operate that. We want to, have other organisations run airlines with it, or run logistics operations with it, or run kind of communications with it. That's not our job. It's not our core skill. We may end up operating the first 2 or 3 just to kind of get the market going. But there's 3 things that it can do. It can stay in the air for a long time. So that relates to any kind of geo-survey type work, academic research, particularly about climate change in difficult to reach places. So, sort of watching the Arctic Circle and the ice extent in the North Pole, that kind of stuff. A kind of search and rescue, a communications, a new, a filming platform, etc., etc. And you can kind of combine that. So imagine you have the Olympics in Rio. You have both monitoring crowd flow, you have a film crew on there, and it's also advertising. So it does a whole bunch of stuff all at once. The next is cargo and freight. And so we can go at about, and comes back to your question about engines, at the moment we've got pretty much standard light aircraft engines, 4 of them, but they're housed in a bespoke unit which makes them a bit more efficient. And we can go up to 85 knots at max speed, which is near as you like, 100 miles an hour, 160 kilometers per hour as a max speed. We'd probably normally go a bit slower than that because it's more efficient. But we can then carry freight and cargo and particularly semi-perishable items, or just items that are difficult with the current one, and then we will make a bigger one which will be much more like a roll-on, roll-off ferry, which will be capable of taking ISO containers and just sort of dropping them off from A to B, wherever we want in the world. And then finally is the passenger market, which we're doing a piece of work with Judge Business School at Cambridge University at the moment, trying to analyse what we think the passenger market is. One of our thoughts is that could potentially be the first use, but it comes back to we're being responsive to other people's needs, and each different use requires a few different tweaks to the payload module, to kind of how the aircraft works. And each one of those tweaks, it sounds like a tweak, but with regulation of airspace and the Civil Aviation Authority and design and everything else, probably costs us anywhere from £500,000 to £1 million. So it's not cheap just to convert it from
That's a tweak, yeah.
Yeah, a surveillance role to a cargo role or to a passenger role. So we will be driven by which use has its first market, and it may well be passenger. And if it is passenger, we'd be probably looking at running passenger services from as early as a sort of mid to late 2016. But I'd say realistically, it's kind of 2017 before we do that. But at some stage, we will definitely run some sort of passenger aircraft, and it might be experience flights, it might be dining cruises over major cities or over, sort of the Grand Canyon or the pyramids. It might be safari by Airlander, and it might be more sort of workhorse commercial point to point. So we had a chap called Daniel Moylan, who's Boris Johnson's aviation advisor, come and visit us a few weeks ago. He's sort of almost as bonkers, probably more bonkers than Boris, to be honest. He's a fascinating guy. But we were discussing the idea of putting a platform, and it doesn't need to be super strong because we're light, but a platform over St Pancras Station, where you've already got the existing infrastructure with Eurostar, with customs, whatever, and then just flying short-haul routes to Amsterdam, to the rest of Europe. That's the sort of portable Eurostar comment.
Yeah, I mean, I can imagine Boris being the first one to fly in the craft, actually. But
Yeah.
did you say, by the way, that actually you're going to make a much bigger one than the one you're currently near right now? So you see these things getting a lot larger.
Yeah.
Than the tremendous size, as a 900-meter hangar you're in at this time. I just wondered whether is size at all a limiting factor on how many you can have, because you must be in a very large facility right now. I mean, we have enough trouble with airports and stuff. So I just wonder, do you see size a limiting factor, or do you think the size will just vary so much that it won't be?
Size, that the fundamental with anything that's lighter than air, the bigger it is, the more capability it's got. And if you think if you double the length, because it's about the volume of the lift gas, the volume of helium in our case, that you put in there. And I should emphasize, helium is an inert gas. It's very different from hydrogen that burns, which I've seen pictures of
Yeah,
here.
thanks
So
for that clarity.
we've got a very safe aircraft. For every doubling of length of a volume of a gas, you get a cubic relation. So you basically get 8 times as much lifting gas. So you just get this disproportionate effect when you make them bigger. And if you think this hangar was developed for the British competition to the Zeppelins in the 1930s, that's why it's 900 foot long, which is what the airships of old were. We're 300 foot, so we can expand into this space. The Airlander 50, which will carry somewhere north of 50 tons, probably 50 to 70 tons, are much more powerful turbofan engines on it. That is envisaged to be about 120 meters long, which is 400 foot, so another 100 foot on top. And just to put that into context, so we're 92 meters, a 747 is 76 meters. So we're kind of, whatever that is, a quarter, third more. And the Airlander 50 is almost double, or getting on for double what a 747 is. So they are big. The hangar, the limiting factor on the hangar will be the width, because we fly like a wing. We're a lot wider than traditional airships, and so at some point we'll have to move to a new hangar. But hangars can be built to house that, but it's not something you want to invest a lot of money in early on. You want to get the technology out there and then worry about the sort of building space for it. You just use whatever is existing and cheap and affordable to start with.
And actually that leads on to another question I think that is interesting to ask, is that how difficult or easy are these? I mean, you've spoken a bit about the cost of them. How difficult or easy are they to construct from a manufacturing point of view? I mean, what material is that actually made out of, the Airlander craft?
If you ask me, it's just so easy to make. And as I say to our engineers all the time, it's like, how hard can it be? You just got a big. I've got. I'll just point the camera in that direction. An incredulous head of flight science is in the room over there, just looking at me. And all you're doing is filling a big, helium-type bag of helium and chucking a few engines on it and a place to put some pilots and cargo. That hard. The reality is it is very hard indeed, because it's entirely new technology. It's flying in a completely new way. Just the wind tunnel testing, the sort of airflow, how the vortices work, how the power of the engines work. It is hard, and aviation is a hard business, and it's expensive business. And whether you're trying to get into space with passenger aircraft, or you're trying to sort of do drones to deliver parcels, or whatever new technology, there's so many hurdles to get through. So it's a difficult and expensive business. We've got the most experienced team in the world to do this, but let's not kid ourselves that doing something new in the aviation space is a difficult and expensive business.
Cool. Well, we've got a couple of questions coming in here now, and I will get to those now. I just wanted to remind our viewers that there's two ways you can talk to Chris. Well, send questions to Chris, and I'll talk to Chris. One is via the Google Hangout Q&A app, which you can just access by clicking somewhere on your screen. It will either be in the bottom left or right-hand side, and the other is by tweeting us at ThinkDev. So the first one that's come in, actually, I think this viewer may have joined right after you made this point, but I wondered, it's quite a sensitive issue, so I think it's never a bad thing to clarify. They said, sorry, just joined. You must get this all the time. Hindenburg. What's changed to make this safer, and how do you put people's fears to rest? So we have a few comments earlier about this, but I think, like I said, I think it's a bad thing to reiterate.
The biggest communication issue we've got is Hindenburg, and you know that one of the reasons it's probably 20th century. It's probably the most iconographic visual news story. You know, seeing this huge thing, and it was huge, and you know, it done 127 flights safely, not a single passenger, not a single mishap, and then suddenly this thing just sort of blew. But what's interesting, even with the Hindenburg, is half the passengers walked away from that scot-free, which you sort of don't think if you see it. But it's constantly, we're bombarded with that. So number one, we have helium, not hydrogen. Helium is inert. It's a noble gas. It's called noble because it doesn't react with anything. So it's got its nobility that it stays, you know, to itself. And what helium will put out any reaction, anything else. We've got 4 engines. We can fly on one. We can fly on none. We've got video of a emergency landing. Our emergency landing is we float gently to the ground. We don't, you know, do it. So we did a whole piece of research with the US Navy where we had a catastrophic simultaneous all-engine failure, and all that happened is we sort of gradually sunk to the ground and landed, you know, perfectly nicely. The material our hull is made of is Kevlar, which is the same as bulletproof vest, and a carbon fibre weave, so it's super strong. And we've had tests where we've fired bullets at it, and the helium's under such low pressure it seeps out. And there's lots of stories, I mean, history of airships where they've been hit by bullets and the pilot hasn't even known till he's landed because it takes hours for the lifting gas to seep out, and there's just a lot of it. So yes, it's a big communication issue for us, and we know that, but these are probably the safest form of flying available now. But you know, I will be saying that for the next 50 years, and I know it's, you know, people will challenge that all the time.
I think it's a great point as well that, you know, some of the forms of transportation we use very often and are not 100% safe. It's not 100% safe to drive a car or to use a regular airplane transportation.
Yeah.
So there's a couple of questions about performance coming in. There's one about speed. They're asking, I mean, at the moment, I think the speeds are projected quite low, or at least that seems to be the impression of this user's expectation. It's not going to be that fast. I think you did mention some of the capabilities earlier.
Yeah.
What do you see as the potential? Is you know, is it always going to be a slow transit vessel, or is it likely? Are there opportunities there as well?
We could. I mean, basically, 100 miles an hour is what it goes at, which compared to anything other than jet aircraft puts us, you know, kind of in the ballpark. And with all the rest of the convenience of landing and taking off from anywhere, etc., that's as fast as you need to be. The limiting factor on speed really is because we've got no internal structure in order to keep it light. So unlike airships of old, which had lots of sort of aluminium framework that everything was put over, it's the helium inside that maintains the shape of this. And if you imagine, you know, if you're driving along in a car and a motor, you put a balloon out the window, that balloon gets kind of scrunched up at the front end when the air hits it. So if we do much more than 100 miles an hour, the shape of the aircraft itself will start changing, which will start changing the aerodynamic nature of it, which is crucial to our performance. So that kind of is a limiting factor. However, what we could do is, have sort of like a steel toe cap on a metal boot. So we could make the front of it rigid and then not have to worry about that issue. But there's a whole, raft of design work, thinking work, engineering work, CAD work in order to develop and prove that technology. So yeah, at some point they will go quicker, but that point is probably 10 years away, just in the normal design cycle of an aircraft. And the Airlander 50, the bigger one, will naturally go quicker anyway. It's about probably 120 miles an hour, but they'll sort of creep up in that range. But for the use that we're looking at, we don't see that they need to go much faster than that. There just isn't a bigger need.
Yeah, no, that's fine. I've got another question, sort of, I think it's related to performance, and I've got one of my own that's, I think, is linked to another question we received. Do keep sending your questions in as we go through the session. So we've had one: how resilient is the Airlander in adverse weather conditions in comparison to, say, a 747? So I guess they're thinking about, if you're in the middle of a storm or something, is that an issue?
Yeah. So we are regulating designated flight in exactly the same weather conditions as any civil airliner. So if an airliner is flying, we will probably be flying. Now, because we move at a slightly slower speed, what we would do, in the same way that, let's say, an ocean-going yacht, which, obviously with Dame Ellen Carter will know about this, you look at where the weather systems are and you go around them as much as you can. And, if you're in the middle of a 100-mile-an-hour wind, that's not a good place to be. And that's not a good place to be if you're a 747 or you're an Airlander. So you sort of move around and you use the weather systems to your advantage. And now, we've got the technology available to do that all the time. But we can basically fly in the same weather conditions as an airplane. And the reason for that is because we fly like an aeroplane. And we don't fly like the airships of old, which were very weather constrained, and that's why we developed this new technology that combines basically the wing shape with the airship.
I just wondered, do you have any sort of figures or rough ballpark figures or statistics on the energy efficiency of the Airlander compared to other methods for doing some of the initial purposes, like, for example, I don't know, monitoring in the North Pole, that sort of thing? Do you have any idea how much of energy saving you can offer? In terms of cost and in terms of money, in terms of energy.
We've done a lot of modelling of this based on test data, because we have actually flown this aircraft full size back a couple of years ago. I did a 90-minute flight, and we've done lots and lots of testing. So we kind of know the data reasonably well. We still need to do a lot more. And all of our data suggests that, like for like versus helicopter or an aeroplane, we burn about 20% of the fuel, and we're about 20% of the operating costs. So it's a massive saving, and it's not validated. So one of the main operators of helicopters in the world, we shared our data and our spreadsheets with them, and they came back with this same figure to us, and just basically, it sort of blew them away that they said, well, we need one of these tomorrow, because this is just going to change the market for helicopter transportation that, at the moment they're market leaders on. So we kind of know that the figures are stunning. As we get through the flight test program next year, we'll understand a lot more of that, and we can hone down. They may be slightly worse than 20%, they may be slightly better than 20%, but that's a sort of ballpark, and it kind of depends a bit on the task that we're doing.
I mean, that would be an incredible achievement. I certainly wasn't expecting you to say 20% of the cost, maybe 20% saving, maybe. I think we've got a question from Jules here that I'm going to ask, and then I think that'd be a good point after this question to have a little look around the hangar, which I teased you guys with beforehand, so we are going to keep our promise. But Jules's question is, I guess, a very reasonable one to ask, which is, and also a very difficult one to answer. How do you see this scaling over the next 10 years? I mean, I guess it's where do you see this going?
Okay, so we actually, I think I can answer that quite sensibly, bizarrely, because I don't often answer things very sensibly. We had a independent market study by the top aviation kind of research company, And we know they're the top guys because this study was paid for by one of the world's largest aircraft manufacturers, and they were worried that their cargo variants of their aircraft that they make were going to get cannibalized and wiped out. And they were sufficiently worried that they paid 75 grand to do a big market research piece on it, which they shared with us. That market research piece said right now there's a market for 600 of these worldwide to do existing tasks. That's not. Then they were very tight on the parameters. You imagine a large blue chip organization gives them a very tight parameter, and it wasn't looking at all the new and different stuff that is being covered by trucks or railways or ships or any other thing, or just not being done at the moment. It was literally, what are aeroplanes doing at the moment that this would take over? And and they sort of graph that out with these beautiful graphs to sort of how many are going to grow and how's the market going to grow. So over 20 years, I would envisage these aircraft would become as ubiquitous as helicopters, and you'll see them all around, and I'd imagine there'll be thousands of them, and hopefully by then it won't just be us. Again, we've had lots of validation that we're about 3 years ahead of the next best competitor, and there are other competitors, and Lockheed Martin have got a half-size version of this. So we'll get to the market first, and we'll enjoy that free run for a few years. But everyone's going to catch up pretty soon, and in 20 years' time, it's not just going to be us. You'll be able to go on a Lockheed Martin version, and probably an Airbus version, and an ARV version, and I think the world will be full of this, and they'll all be slightly different variants, but they'll all be on the same theme of mixing a wing and an airship. And interesting, Lockheed Martin, which is probably the next biggest competitor to us, have got something that looks very similar to ours, certainly to the layman's eyes.
Oh, that's very interesting. We are going to do this hangout tour now, but we did have another question right in actually that is linked to that, which I thought I'd just put you now. Is that have you seen any other examples of this? So it's interesting that there's almost like a market shift to that this is obviously needed. I suppose the question there is how much variation do you think there will be between these different types of Airlanders, future Airlanders, whatever they're called, compared with say current aircraft today? I mean, are there going to be very specialist airships, or are there going to be how much room is there for innovation in the technology still as well, I suppose, is the sort of question there that some of our audience members might be interested in.
Huge amount of room. So the sort of starting point of this, really, I mean, people have looked at doing this kind of airplane wing and whatever ever since airplane wings really started. So in 1910 people coming up with hybrid aircraft concepts. The first proper one was a small-scale demonstrator in the States in the mid-70s, which looked like, it was called the deltoid pumpkin seat. So it looked like a sort of delta wing full of helium. So that's another shape, which is very different from ours. Ours is born out of proven airship technology that's mixed with a wing. At some point, somebody's going to come in from a wing background and go, well, I've got a wing here that works brilliantly. All I need to do is fill it with helium and put a different cover from it. That's all you need to do, my classic kind of non-engineering, how hard can it be? It's a difficult task. The Airbus concept one was two cigar-shaped airships joined by wings. So there's lots of different ideas. The trouble with any innovation in aerospace, it costs stupid amounts of money. So that's the limiting factor, and it's very highly regulated. So that's probably going to be a limiting factor for a plethora of designs. And what I think will happen is ours is the first full-scale version that's ever worked, and I think there'll be lots of sort of copycat version of our technology before somebody goes, oh, let's do something completely different. And in the same way, I used to walk past we had an office in Cranfield University Innovation Centre, and I walked past the vortex diagram or picture of a winglet on the end of an airplane wing. Anybody could have invented winglets for 100 years, and nobody actually did till 25 years ago, and it's sort of only slowly got adapted. And that saves 30% of your fuel burn. and just nobody came up with it because people aren't incentivized to come up with that grand scale of innovation. So yeah.
Yeah, that's so Chris is now going to take us, I
Yes.
believe, into the hangar. In the meantime, Chris is very happy to still answer your questions, assuming his internet connection survives this. But
Yeah. I'm going to put my hard hat on because we're in a hard hat environment.
we're happy to receive questions both via the Google Hangout function, so that's either going to be in the bottom left-hand tab of your screen or on the right-hand side, or Twitter via ThinkDiff.
Right. So what we've got, as I sort of walk around here, you can see in the background, this is the kind of pilot module. I'm doing this just from a normal laptop, so it's probably going to... So that's where the pilot sits. That's not attached to the aircraft, and you can see the aircraft here, and I'll just move. We're actually all in darkness at the moment for some reason. We've got a light up here. I'm walking along the side of the aircraft here, and you can see the sort of size of it. That's where one of the front engines gets attached. Just those are sort of round, oval-like attachment points, and so it takes quite a long time because we're quite a big aircraft. So if I move to the kind of front here, unfortunately I don't really have a zoom feature on this. That is, you can kind of see now the shape,
the size
forming, and you can see the kind of double hull nature of the aircraft there. And we'll just I'll just try and move a bit to the front so we can kind of see. This is often referred to as the Jennifer Aniston bottom shot.
I thought that sound was it taken off for a second, Chris.
Yeah, no, there's all sorts of real engineering stuff going on here. So that's so yeah, you can just see, and the lighting's a bit funny because we've just got a lamp there, but you can kind of see the sort of double hull shape there, and where the pilot...
Can you just tell us a little bit about that double hull shape? I think you did describe it a little bit earlier. I just wonder if you could walk us through it.
So that allows, basically, you've sort of stretched an airship sideways, so it gives it an aerodynamic shape. So 40% of the lift that is generated comes from aerodynamic lift, which is basically being a wing. And so this, the engineering is actually quite complex and clever, that it all sort of links into both holding the payload module that goes at the middle bottom of where the airship is. It allows, and comes back to a safety feature, you've got 12 different compartments in there, so even if you lose half the airship, you've still got enough helium to keep you aloft. But fundamentally, it's that the shape, by stretching it out sideways and having that double shot, you've created a wing. And so that creates an enormous amount of lift. And you only need around 20 to 30 knots of wind over the top of it, which is kind of nothing compared to an airplane, to generate enough lift to get it airborne. So that's sort of where we are. And you can see the size of the hangars that we're in. You can sort of, the windows there. This is a wind wall which is only halfway across the hangar. So the whole thing is just sort of an enormous enterprise. And at the moment, some of the noise in the background is just we're creating an engine test rig at the moment. Engines on full power, which we're going to do over the next couple of weeks, and then we've also got a whole bunch of wind tunnel testing going on. So I'll just try
yeah, perhaps you could talk a little bit about the work that's sort of going on right now. So this ship is in a process of being tested, I guess, and this one has been flown before.
So this got flown in the United States under US Army program. We bought it back about just under 12 months ago. We had to ship it back because we hadn't done enough hours of test flying to fly it back. And so what we're doing now is we're going through 30,000 parts, just testing them, making sure they're airworthy, and in effect rebuilding pretty much from scratch the whole aircraft. But we've got all the bits. We know the design works, and we know all the bits work, but we've just got to sort of retest them. And for example, the fins, we need to do a bit of reskinning of those. And but it's all there, and we'll just gradually go through the process over the next few months of attaching everything, testing everything, and then we'll be flying it sometime next year.
So that's in 2015 sometime?
2015, yeah. Probably, I'd sort of put late summer roughly as the date, but it depends on lots of factors, and we don't. The last thing we want to do is commit to a date and then either force ourselves to do something when we're worried about a safety feature, which we don't. We never want to have that issue, or kind of commit to something that we're not going to deliver on.
And so, I mean, it's interesting that, I mean, some of the dates you're talking to, I mean, you talked about the possibility of flying passengers in 2017. So,
Yep.
I guess your timeline suggests that, once this has been proven in the end of 2015, you expect it to accelerate extremely quickly.
Yeah, and also because we've flown it before, once we need to do 200 hours of test flying, and then and again, one of the reasons why it might take shorter or longer is the level of certification we go for initially. There's a whole regulatory debate that we're having at the moment, and but as soon as we've got one, you're away. You're done at that point, and we've got the technology to make these fairly quickly once we've started the process. So it's we kind of envisage a pretty rapid rollout, and certainly we're sort of envisaging a production run of 5 to 10 a year within 5 years.
What do they like to fly? Can I fly one? If I mean, is it the same criteria as a pilot of a jet plane, or?
Yeah. Sorry, I've just got the back here. Yes, it is. So it's a normal aviation license. If you're commercial, you have to get a commercial pilot's license, and the rating, the type certification, is what you need to do. And how you do that is turn up with your existing license, persuade Dave Burns, who's our chief test pilot, to sit in the seat next to him for 3 months, and then effectively he signs that off that you're capable of flying, because he's the only one who actually knows how to fly one of these. And we've got a flight simulator here that we train people on. It's a bit basic, but it sort of gives people the sort of feel of how everything works, and we'll update that flight simulator as we progress.
So it is a different skill set from regular jet flying in some ways, or there are different things that people need to be expert in, I guess.
It's Dave Burns, who's our chief test pilot who flew in the States. He reckons the best people at it are people who've sort of flown multi-engine transport aircraft, because they kind of understand multi-engines and they understand how an aeroplane works. And there's not many airship pilots in the world anyway, so that's just a small number. But it's significantly different from an airship, so those aren't that good. Helicopter pilots are sort of fly in a different way, and fast jet pilots just think too quickly. I mean, Dave's view is that his first thing in any emergency situation is go to the back of his cockpit and make himself a cup of tea and think about it, because that's sort of the mindset. So it's much more like being a sort of ocean-going yacht or a big ship type pilot, and I think it will become its own class of pilot. It'll just be a different type of pilot.
Great. Are you just popping back into
the
I'm
popping back.
Yeah, so
sure.
we are now just about out of time. There is one more interesting question I'd just like to, from our audience. I'd just like to put forward to you as a sort of concluding question. I think we've covered this a little bit now, but I think it's still a relevant and interesting question to conclude with. It's from Daryl, who his question is, why do you think this innovation is only coming now? Since we've been using traditional aircraft for 50 plus years without much change. So I suppose, why is the time now?
Yeah. I think fundamentally it's a question of computers and material technology. Without having, so the early days of right through to the 40s and 50s, how innovation happened in airplanes was people just built airplanes. They might have built them out of balsa wood or lightweight material and just tried them out and just seen what they did. And so the Wright brothers didn't know much about what the optimal wing shape was. They just kind of like, well, this seems to work and let's fly it, and lo and behold, we can take off a bit. So what has happened is the power of computers have allowed people to play about with designs, number one. the materials technology now is sufficiently advanced and sufficiently efficient. So all of our material is carbon composite, and so it's strong, it's light, and it sort of allows a lot more capability. And I think just the you know, it comes back to the whole, which has probably been covered by the whole festival, is, you know, how do people innovate and why do people innovate? You know, it's sort of, aviation has become a very much a big company business. Big companies don't innovate very well because nobody's incentivized to innovate. They're incentivized to do something 1% better than the last person did or they did last year. And there's just, nobody will ever innovate because that will take the risk to make something 20% better in one leap. It's just not worth anybody's time or effort. And I think that's, you know, there's all those factors working against it. But as I said, you know, people have been trying to do this kind of hybrid aircraft technology for 100 years pretty much. And you know, we're the first people really to get something that's big and scalable and right. But I think any of the projects in the last 100 years, particularly in the last 30 years, if they'd had enough funding and enough gumption behind them, could have worked. You know, the technology was good enough, but you know, we've happened to have had, you know, a nice break that the US government effectively invested north of £100 million worth of research and development in the aircraft, which has helped somewhat. And you know, and we've got the right people and the right idea. So you know, I'm thinking we'll succeed first, but others will follow.
Well, thank you very much, Chris. That's a great answer to finish on, and I really appreciate it. It's been a fascinating and really interesting conversation that I feel like I know a lot more about it now, and it's very exciting. I look forward to seeing how it develops over the next couple of years as well. Thank you so much for taking the time to show us around the hangar and to talk with us today. So glad that we made it work after our initial technical difficulties, and thank you to our audience who submitted some really interesting questions and then your attendance and presumed attention. I will highlight to you just a couple of quick sessions that are happening later today as a part of the Disruptive Innovation Festival. We've got Michael Beutler at 5 o'clock GMT, so in 45 minutes time, talking about making natural capital a part of your company, and so more complex understanding of the costs and profits also of companies and the fantastic work they've been doing at Kering there. At 6 o'clock we then got the guys from HP Printing talking about latest innovation that they've come up with in the 3D printing space. So that's also a session not to be missed. Do try and catch those two sessions, and many other sessions, including I believe this one, will be available on our archive for 30 days after the diff, which finishes tomorrow. So there's plenty of time to catch up with any sessions that you wanted to see but missed. Chris, thank you so much again for being with us today. Really appreciated the time you've taken, and thank you for a really interesting insight into the future of aviation.
Thank you. It's a pleasure.